Okay, before we get started, just a brief overview of what's going to be used here. This is a DSL modem connected to Ether 3 on the 433 board, and then on Ether 2 I have a Ubiquiti nano station in the window pointed to a access point about 4 miles away through those trees there. If we come back here, if we look at the Mikrotik board here, I have a 5 gig card that's going to act as the AP once these connections are bonded together. This is just power over Ethernet to power the board from the injector here. This is a Ubiquiti Nano 5 gig nano bridge that I'll use as a station once everything is set up.
Hello everyone and welcome back. As you saw from the phone video prior to me sitting down at the laptop here, we have all of our equipment laid out, plugged in and ready to go. The first thing you will have to do in order to make use of PCC routing in the Mikrotik board is you will have to identify the network settings for each one of your WAN connections. So in my particular setup here, I had the 2.4 Ubiquiti Nano station connected to an access point a few miles away from my home here. And I have that set in routing mode, and I have it an IP address of 192.168.3.1. And I also have a DSL modem set up with an IP address of 192.168.4.1. And then on that Mikrotik board, we also looked at the 5 gigahertz wireless card, and we're going to use that as our link out. So these two connections are going to flow together and come out this 5 gigahertz card. And this is how I started out producing my bandwidth. This was my first hop. I had two hardwired connections coming into a Mikrotik, and then I sent it out on a 5 gigahertz backhaul link to my first access point. And that's how I recommend everybody get started. It's very simple, it's very basic, and I'm going to go ahead and show you how to do that right now. So the first thing we're going to do is log into our Mikrotik here. I'm going to close out and pretend like you've never been into a Mikrotik before. I'm launching Mikrotik's Winbox utility. I'm going to use the drop-down list to discover my Mikrotik 493 board. I'm going to click the MAC address and I'm going to click Connect. And under interfaces, I have already renamed Ether 2, Ether 3, and my 5 gigahertz Atheros card to the specific connections that I wanted them named as. As you can see here, I have it equaling WAN 1, equaling WAN 2, and WAN out equals the 5 gigahertz wireless link out. These two links are registered because they have things plugged into them. The modems behind there. So the first thing we need to do is go into our IP and addresses table, and we're going to add static IP addresses to those specific ports. So interface WAN 1 is going to be on the 3 networks. So we're going to 192.168.3.2. That's a /24 network. We'll hit apply. And it's going to fill in our network and our broadcast IPs for us. And we're going to hit OK. So now that is statically assigned on that interface. We're going to do the same thing for WAN 2. 192.168.4.2/24. And it is a good idea to have DHCP turned off on the devices sitting behind this. I've seen that cause some issues before, where it'll actually assign out one of the statically assigned IP addresses to the Mikrotik to another device. If you don't have any other devices connected to it, I suppose it was okay to turn DHCP on, but we're not using it, so you might as well turn DHCP off on any of those connecting devices. And so we are done with our address list for now. And the next thing we want to do is add some DNS servers. So we're going to go to IP and DNS. And I've already have the two OpenDNS servers set into here. You're going to want to allow remote port requests to make sure that is connected, and then just hit apply and OK. Close out of there. Now you can manually go through and create all of these firewall rules, but I find it far simpler to just use some scripting and enter it through the terminal. So we're going to start a new terminal, and I may have gotten kicked out of the board. real sure what's going on here at this moment. Apologize, folks, and some technical difficulties here. We're going to close out and relog into that Mikrotik board. Sometimes that'll happen when you assign IP addresses to ports. As you can see now, we do have a 4.2 IP address in there, and that's what happened. We got kicked out of the board after assigning the IP address. So no big deal, just close it out, reopen it, and right back where we were, we're going to start a new terminal here. And I'll kind of explain each one of these firewall rules as I add them. The first set of rules are going to be your mangle rules, and what these are going to do, if you kind of follow along here, it's going to mark each one of the input packets on each interface. So all traffic coming in on interface WAN 1 is going to receive an action of mark connection, new connection, mark equals WAN 1 connect. So every packet coming in is going to be marked with WAN 1 connect that comes in on WAN 1. Every packet that comes in on WAN 2 is going to be marked with WAN 2. And the same thing for the output, because as we all know, things will break if traffic doesn't flow symmetrically in and out on the same connection that it came in on. Things like streaming video, HTTPS sites, things of that nature will break. So we're going to add these set of rules first. So the first thing we need to do is we need to go IP firewall mangle. And then we'll just go ahead and copy and paste these in. Okay, everyone, and our next section here is going to be dealing with the pre-routing and the destination addresses. So basically what these rules are specifying is everything with the destination address is going to be accepted into interface WAN out, and that's how our traffic is going to get out. So we'll go ahead and add these in, and these are all going under the mangle addresses, or excuse me, the mangle rules. And now this is just specifying local traffic for interface WAN out per connection classifier, both addresses and ports. Excuse me. So the action is going to be mark connection, new connection, mark equals WAN 1, connection pass through, yes. So we're passing those traffic through. Basically what we're doing is we're marking the address and the port to make sure no traffic gets confused and gets sent down the incorrect links. So we'll add those rules. And the next one is going to be another pre-routing rule. Nope, apologize, I didn't change that from local. Change that to WAN out. And your situation may be different depending on what you decide to name your interfaces, but in this case my interface is named WAN out. And then again, we're just marking them to WAN 1 and WAN 2, depending on where they need to go. I'll add those in. And then our next section of rules is going to be for IP routes. So we'll do IP route. And now here's where we're going to be adding in our gateways. So IP route. And we're going to add destination addresses covering the entire internet, all your zeros. And that's going to be for 3.1, routing mark 2 WAN 1, and destination address 000 gateway for the other WAN 2. And now this check gateway equals ping is basically making sure before it tries to send traffic out there that that gateway is live. That's where our failover comes into effect. So if one of these links goes down for whatever reason, it will not try to route traffic out of it or in from it. And so you have a redundant system here as well as increase in speed and load balancing. So we'll paste those rules in there. And the same thing, we're just doing two separate distances here, distance 1 and distance 2, so that it doesn't try to send out on the same time. Paste those rules in. And again, pinging them before we take any action to make sure that it's there. The next section here is going to be for NAT rules on the firewall, and so we'll get back in there, and we'll get to our IP firewall NAT rules, and then we're just going to chain these together, and we're going to send them in a masquerade. Paste those rules in there. And that's it, folks. We're now set to send all traffic out on that 5 gigahertz link. So what we're going to do is I'm going to go back in here and finish configuring my WAN out connection. We are done with the terminal window. We can close that. So we're going to go to our wireless interfaces tab here, and I only have one. And in the wireless interface tables, we're going to select our 5 gig out channel here, and set it up as an AP bridge. If you're using a Ubiquiti product and not a Mikrotik product as your station, make sure that your frequency is set in the top 4, or else you won't be able to connect to it. I've got an SSID set of dual WAN, and so that's going to take care of all of our settings in there. And then we're going to go out and we're going to go back into our IP addresses table, and we're going to assign a IP address to our WAN out. And we're going to make it a 192.168.0.1/24. Apply there. And also with that, we're going to set up a DHCP server on that WAN out connection, so that all the clients connecting to that will be able to just pull an address. So all I did there is I went to IP, DHCP server, then DHCP setup. Now we're just going to kind of next through this since everything's already set. Those are DNS servers that we entered earlier. Change the lease time if you prefer. Setup is completed successfully. Now, to make sure everything's working correctly, we're going to leave this open. And I'm going to plug in my 5 gigahertz nano bridge that we were looking at earlier when I was showing you everything that I was going to be using for this project. Click the wrong one, I'm sorry. Get off our DSL Wi-Fi here. And I apologize, folks. I'm going to have to actually set a static IP for my LAN card to be able to connect to that Ubiquiti radio. I just want to show you these settings inside there that I used so we can finalize this thing. By default, Ubiquiti radios are on 1.20 IP /24, so I just entered 21 there so that we'll be able to connect to it on its 1.20. So as you see, I've already had this programmed up for our dual WAN access point there. We're connected at a neg 69, pushing 54 megs of data. What I'm going to do now is I'm going to go over here to the network side. I'm going to set this end up as another. Let's set this up as a bridge, and it's going to get a DHCP address because remember we set that access point up to give out IP addresses. And then we're going to hit change and apply. And that should be all we need to do. I am now connected to those 2 internet connections via the Ubiquiti Nano Bridge, and those 2 internet connections, those 2 WAN connections are coming out on that 5 gigahertz card. So to test this theory, let me close all my tabs here. Okay, folks, now with everything set exactly the way we wanted it, we're going to log back into the Mikrotik one more time. we're going to look at our interfaces tab. Now, this is crucial. To make sure that everything is working, we're going to keep watching our traffic here. So we're going to bring up WAN 1, and we're going to bring up WAN 2. And we're going to pull up the traffic tabs. And as you see, not a whole lot flowing right now. See if I can get this at a better angle here. That should work. Now, see fairly even amount of traffic flowing through each one of those connections. This IP is showing up as 38.104.162.142 for this specific test. That really just depends on what packet falls where across your LAN when you loaded the speed test page as to which IP you're going to pull. But as you can see, we're receiving about 2 megs there, and on my slower link I'm getting right around a meg, just under a meg. For a combined 2.4 megs down. And now we're going to just transfer 25, 170, 34, 179, and 95 for a total of about half a meg. Now, to put it in perspective, each one of these links is right around a meg and a half. So that 2.4 that we're seeing is fairly accurate for what we should be pulling. If I load the speed test site again, and we'll do it one more time. Eventually I'm trying to get it to show the other IP address associated with this connection. May have to close out of Firefox completely. Yeah, now we're showing in a Frontier Communications address of 74.34.82.227. So as you can see, our load balancing, bonding, and I'll show you here in just a moment that failover is also working. And our tests are looking much better this time. And yeah, if you can see those bar graphs there, we're getting pretty symmetrical readings across both connections, so it's using both of them fairly equally. And we'll go over to Speakeasy. Now let's pretend that something happens on WAN 2 and it's no longer functioning. And to test that scenario, we're just going to just completely kill WAN 2 by disabling it. Minus the reduction in speed, because we're minus a bonded connection now, you or your customers are never going to notice anything has happened. Traffic will continue to route normally. Everything's going to go in and out exactly as it should. So as you can see here, we're down to 1.77 megs. As you can see, the upload on this connection is actually much better. And on another tutorial, I will show you how to account for differentiating links. This link is actually faster than the other link. So I'm going to turn WAN 2 back on now, and we'll run another test. And things aren't quite warmed up yet, so it's not pushing exactly what it should be. do a refresh on the page here. And now you can see we're jumping right back up there where we were, right around 2 to 3 megs. If you can see our traffic here, we're staying pretty evenly keeled across both links, which is exactly what you want to see. And this also will not hurt streaming video, as some forms of bonding a connection will. So as you can see, we're streaming along here just fine. Some forms of connection bonding will actually hurt secure websites and streaming video, and those will break and not function. But this method will not. You see that's playing along just fine there. So I hope we all learned something. I know that I did. And if you have any questions, please ask in the chat area. And everybody have a great weekend. Bye.